we're going to take a look at polynomial and rational functions. We are shifting gears away from logarithms and exponents. So we're going to know the meaning of a division algorithm as our first step. Then we're going to do some synthetic division. Don't panic, it's not that bad, I promise. And we're going to use the remainder theorem to evaluate a polynomial. This remainder theorem is not going to be terribly helpful to evaluate a polynomial, but it's going to be helpful later when we learn to talk about remainders. Then we're going to decide whether something is a zero of a polynomial function without looking at a graph. So we want to know the meaning of the division algorithm. So the division algorithm gives us some example statements like let f of x and g of x, they're polynomials where g of x is a lesser exponent. So that'd be x cubed and x squared, where g of x is x squared. There exists some polynomial to where I can multiply g of x by a value and add something to it, where either it's going to be 0 or the degree of r of x is less than the degree of g of x. You're not expected to give me this on a test. You're not expected to explain this to me in the lab, but I do want to introduce you to this idea of where this comes from. So when we go to use synthetic division, we're pulling from that division algorithm, and that's what's allowing us to do synthetic division. Synthetic division is a shortcut for long division. So if you remember when you learned long division, chances are your teacher hammered it home and made you do it several times, and then they said, oh look, there's this beautiful thing called short division, or a shortcut to division, and that's probably how you divide today. The synthetic division is a shortcut to long division of a polynomial. So if I want to use synthetic division, I'm going to say x plus 3, and here's the thing, guys, k is always the opposite of this value. So it's what makes x plus 3 equal 0, so that'd be negative 3. I put my negative 3 on the outside of my division, and I list the coefficients in order. So these have to be going down in order. And if you're missing a term, you put a 0. So that's where these come from. I'm going to bring the 2 down, and I'm going to multiply 2 times negative 3 to give me negative 6. These are cool graphics, right? Then I'm going to add 13 and negative 6 to get 7. Then I'm going to do negative 3 times 7 is negative 21. I'm going to add those together. I get 9. I'm going to multiply negative 3 times 9, and I get negative 27, so I get negative 2. So the division, you take the coefficients and you're taking 1 away from the exponent. So this is 2x squared instead of cubed plus 7x plus 9, and then we write the remainder as still being divided by that original value. Unless the remainder is 0, at that point you leave it off. So let's divide again. It's x plus 2. Remember, we're putting what makes x plus 2 0 on the side. So that would be negative 2. I'm copying down my coefficients. Notice I don't have an x squared term, so I put a 0. I bring the 3 down. I multiply negative 2 times 3 is negative 6. I add 0 and negative 6. Then I'm going to multiply. Negative 2 times negative 6 is 12. Add them together. That should be 10. That's an error in the PowerPoint. 10 times negative 2 is negative 20, which leaves me with a remainder of 1. So this should be 3x squared minus 6x, that should be a 10, remember from the error, plus 1 over the remainder. So I have 1 over that. Now notice, this does not have an x squared term, but when I actually divide it, there is an x term and an x squared term. So try not to make a rule or a pattern with that, because there isn't one. If I divide any polynomial by 1, I get my coefficients and my remainder so that I can factor it out. I could do the same thing for 2, 3, 4, but it may not always divide evenly. So I still have that minus 1 hanging out here. That's what that is. Use the remainder theorem to evaluate a polynomial. So this is not as useful, I think, as a lot of different properties, because if I'm looking for the f of negative 2, me personally, I'm just going to replace x with negative 2 and plug it straight in my calculator. I am probably not going to use the remainder theorem. However, later on in your math courses, that's going to be some helpful information. So I put negative 2 in the box because that's what I'm trying to evaluate. I bring the 1 down. I multiply 1 by negative 2. I add them together. Multiply by negative 2. Add them together. Multiply by negative 2. Add them together. And what you should notice is if you plug 45 into the equation, or negative 2 into the equation, you would get 45 out. So do you see it's kind of a long process to get there, so it's not the most useful thing right now, but it will be useful. If something is a zero of a polynomial function, there's this huge math explanation. Here's what it boils down to. The remainder is going to be 0. So if something is a factor, what we call a factor or a zero of the function, the remainder is going to be 0. So again, this is where that remainder is helpful. So if I want to know if 3 is a zero of that equation, there are two ways to do it. There is the long way, which would be synthetic division. So I'm going to copy all my coefficients down. I'm going to perform the synthetic division process. And I see that I get 0 as a remainder. Here is Miss Robinson's hint. I would not do it this way. I would plug in 3 because we know the remainder is the same thing as plugging in. And if I plug in 3 and I get 0, then I know that it's a factor. It's a 0 of it. So two different ways to approach it. I would just plug that thing in. I'm not trying to do synthetic division if I don't have to. And you can do that in the lab as well. Now this one, that's a little more tricky to plug in, right? So I can use this synthetic division process to figure this out and I get 0. Why can I use synthetic division and why is it harder? I don't want to plug in 1 minus 3i and do that to the 4th power. That would be very difficult. So in this case, that multiplication is going to be nice because you're going to just have to FOIL this. So this times this, I'm just going to FOIL those two terms, add it to 11, FOIL, add it to this, and FOIL. You're not quite going to have as tough of a time with that as you would trying to do just this term alone.